Hi students, welcome to our channel Physics Concepts by Alisa. Here in today's session, now we discuss about energy of the particle in the simple harmonic motion. So energy is basically we can consider kinetic energy, potential energy and the total energy. Apart from this one, in this session we will draw the graphs also for these energies. Most important topic this is. Now let us see. The first of all, what is the expression for kinetic energy? So we know that kinetic energy means half mv square. Again, the velocity in a simple harmonic motion, a omega sine omega t. So keep this equation. Now we know that a omega cos omega t. A omega cos omega t we can consider cos omega t. Then again cos square omega t plus sin square omega t is equal to 1. So cos square omega t is equal to 1 minus sin square omega t. So here is now let us take a reference circle. In this reference circle, now if we suppose to take the any one particle is, then in the project the particle is a p particle moving with omega angular velocity, and so it is making a omega t angle. Now one draw perpendicular to this y dash, then we will get here is now let us take any one particle consider as a x. So here is now the radius is a, now consider this is y. So this is also omega t. Then what we will get now for this sin omega t. Now let us take this part here. Then if we suppose to take the triangle we will get here, and this is omega t and this value is y and this value is a. Then sin omega t is equal to how much is that? Opposite side by hypotenuse. So we will get sin omega t is equal to y by a. Then we will get ultimate understood now how we will get sin omega t means what we will get. Then we will get y by a. So substitute this value here, 1 minus y by a means y square by a square you take. So cos square omega t is equal to, take the LCM, then we will get a square minus y square by a square. Substitute this value, then here is again. Now what we need only cos omega t. So then what we will take for this one? Cos omega t in sense, then what we will get here is, so that is equal to square root of a square minus y square by a we will get. Now let us apply this expression in this expression. So then v is equal to a omega, instead of cos omega t, then instead of this cos omega t we will write this one. So a square minus y square by a, then we will get, and here a get cancelled, v is equal to omega square root of a square minus y square. So we got one expression for the velocity now. So here now let us substitute that value in this one. So then Ke is equal to half mv square, that is equal to half m, p value how much? Omega square root of a square minus y square, these are whole square, that is equal to half m omega square into a square minus y square. So that is equal to half. This can be considered as k into a square minus y square. This is the kinetic energy expression, very popular. So here is the k is equal to half k into a square minus y square, half we got. Now let's discuss about this. So if a particle is there in the mean position, so mean position in sense the displacement is equal to 0. The particle is moving towards extreme position, that is the maximum amplitude. So again if we suppose to move this side, that is a negative amplitude we can consider. Let us substitute these values here. Then how the kinetic energy will changes, let us see. First now let us take a mean position. So at mean position, at mean position that y displacement is equal to 0. Then Ke is equal to how much is that? Half K in this A square minus G square. So ultimately how much will get? Half K A square. Means at mean position K is maximum. How much is that? Half K A square. Now let's take in the extreme position. This is we are calling as extreme position. So in the extreme position y is equal to a. So Ke is equal to how much is that? Half K into a square minus a square. Why? Because this is y is equal to a. How much will be that one? That is equal to 0. Means at extreme position Ke is equal to minimum. Of course we can consider as even a 0 also. So the kinetic energy is maximum at mean position and again minimum at the extreme position. Now let's draw a graph for this. If we suppose take this is extreme position, this is extreme position, and again then we can consider the graph will be like this. This is the mean position graph what we can take. So this is extreme position, this is the mean position, again this is extreme position, this is the graph for the kinetic energy, then what we can take. So the kinetic energy we can take the extreme position like this. Got it? That is about the graph and expression for kinetic energy. Now let us go the next one, that is we can take potential energy. This expression you have to keep in mind. Half K into a square minus y square. So whereas a is the amplitude, so then y is the displacement. So now let's go with the potential energy. So potential energy we will discuss. Potential energy, what is meant by potential energy? In terms of the simple harmonic motion, if any one particle is in the extreme position, this is the extreme position, this is the mean position. From this mean position, the particle is moving particular distance. We have to find the potential energy of the particle at that particular point. So for potential energy, then what we can consider? The potential energy means it is nothing but the different one form we can consider, that is the potential energy is nothing but it is a work done. If any one object is, now let us take this is only spring. When we compressed the spring, compressed or the stretched the spring. So once when we stretched the string, that string is holding some energy, that energy is called as a potential energy. So this is the spring will do some work, so potential energy can be considered as even work done also. So here is then what is the formula we can take for work is equal to force into displacement formula we can take. For this one, first of all, now let us take F is equal to m into A. So then here is now again that is equal to m into A means omega square x, that formula we can consider. So here is now work done. So dW is equal to, then what we can consider, dW is equal to m omega square x dx. Now let us make the integration from 0 to x. Then that is the work done, W is equal to m omega square is the constant, integral 0 to x dx. Then what you will get m omega square integral x in sense x square by 2, that is 0 to 2, 0 to x. No, so ultimately how much will get? W is equal to m omega square x square by 2. This is nothing but potential energy. So what expression we got for potential energy? Potential energy is equal to half m omega square x square. So m omega square in sense we can consider k, so half k x square. This is the expression for potential energy. P is equal to half k x square. Now let us take a graph for this. So for this graph, now let us take again, then this is the mean position. At mean position, so x is equal to how much is that? 0. So at extreme position x is equal to how much is that? A. And so this one also extreme position minus. Now substitute this one here for this one. Now let's take mean position. At mean position, so mean position, then how much is that? X is equal to 0. So P is equal to how much? Half k into 0, that is equal to 0. Means potential energy at mean position, that is equal to 0. Then what about this extreme position? Now let us take. So at extreme position, how that is extreme position? X is equal to A. So P is equal to half k x square we got. So k a square. Then what we will get? P is equal to half k x square. Means that is a maximum. So this is where it is a maximum. At extreme position, this is the potential energy is maximum. Now let us draw a graph for this. And now let us take this is extreme position. And again here is extreme position. And now the graph we can get this is the mean position. And so this is again, then we can get a graph like this. Means what is that? At extreme position, this is the extreme position. At extreme position, potential energy is maximum. This is the mean position. Mean position, that is a 0. And again this we can consider, this is a extreme position, that is. So at extreme position, that is a maximum, so the graph can be taken like this. So now let us take the total energy. So what is the formula for kinetic energy? So kinetic energy is equal to half m, yes, half m into half k a square, half m, k, half k into, so that is a square minus x square, half k a square minus x square. This is the kinetic energy. And potential energy is equal to half k x square. So from this one, then kinetic energy and potential energy we got. Then now let us go the total energy. So how much will be the total energy? So the total energy we can consider Ke plus Pe. That is equal to half k a square minus x square plus half k x square. So k x square we got k a square minus x square, we got this one. So the expression for P is 1 half k x square, that is equal to half k a square minus half k x square plus half k x square. These both get cancelled. Ultimately how much will get? Half k a square for the total energy. Now let us draw a graph for combining these all. Once when we are taking the graph, this is the ultimate graph, it's important graph that we can consider. Now let us take and here is the extreme position, this is the mean position, this is the extreme position. So before also we have discussed at extreme position. So that extreme position, the kinetic energy, that is at extreme position, the mean the graph, then again we can get this is the graph for kinetic energy. Why the graph? At graph, that is in extreme position, the graph is the minimum, and again it travels like this. Then what about this is again the kinetic energy travels towards this side, and at mean position, this potential energy graph we can get like this. So this is the graph of potential energy. So this graph we can consider, and apart from this one, then we can consider the total energy will be at here, the total Ke, total energy that we can consider here. So here is the graph for potential energy as well as the kinetic energy, the graph. So here is then again we can consider this is the mean position. So then from this equation we can consider at extreme position, that is A is equal to 0. So kinetic energy is 0 at the kinetic energy is 0 at mean position, and at again it is a maximum at the mean position, that is extreme position, that is equal to 0. In that way just we can take the graph of this one. Okay, now I hope that this session is helpful for you. Please support me, Nana. Wish you all the best.